So to start out our second hour, the first topic we have, this is just kind of one you won't be tested on, but I'm going to throw it out there. I'm not even going to really lecture on it because it's not my area of expertise, but there's a lot of vocabulary that's going to be looking at some of the stuff we're going to do in the next couple weeks. And that is on page 150 in your books. The vocabulary covers a lot of things. It's basically just shorthand, medical shorthand, and abbreviations that would be used in dosage calculations. For the most part, I'm going to write everything out so that it's pretty clear what it means. But in a doctor's orders, it might be written out as Q6H. Now, if you're looking on page 150, what does Q6H stand for? Every 6 hours. Very good. So I would probably just write out every 6 hours instead of doing the Q6H. But those are abbreviations that you will need to be familiar with later on. You won't need those for this course, but I'm just showing you that page so you can look at them. In the book, they'll use some of those abbreviations in the homework so that you're familiar with them. On a test, I would write it out more clearly. There's, of course, all sorts of things like, PO means by mouth, orally. IM, intermuscularly. IV, of course, is an abbreviation we will see, just means intravenously, so it's through an IV drip. We'll talk about drip rates and stuff like that. You have the Q6H is every 6 hours. You also have a Q4D, which would be 4 times daily. So things like that, those abbreviations may pop up in the homework. Like I said, on a test, I'll write it out in plain words so that we're not testing on the vocabulary. But just some things you might want to look at. Okay, so the next thing we're going to talk about is dosages. And we mentioned it briefly when we were dealing with these solution concentrations. So if we know how much of a dose that needs to be given, one of the first things we'd be able to do is to give it. So we're going to look at syringes a little bit here. And when we're talking about syringes, we have to talk a little bit about scales and how the scales work. So the scale is just these divisions here. Now, first thing we got to be careful of is on most syringes, the end is not square like the ones I have drawn here. Most of them, it is slightly tapered, which means that first mark sometimes doesn't even appear on the syringe. So the beginning of the syringe, the markings might be a little bit different. So when we're doing anything with a syringe, like trying to figure out what each division stands for, we generally don't start at the end of the syringe. We usually start at one of the clear marks further up the syringe. So first I need to label this one a little bit. So let's say that this is labeled milliliters, and this says 1, 2, 3, and 4, like that. So we need to figure out what each mark stands for. So I'm going to find 2 clearly marked divisions, the 1 and the 2. Again, I'm not starting down here at the 0 because of a taper at the syringe. The 0 point may not be completely obvious exactly where it is. So between 1 and 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. And it's the number of spaces that counts, not the number of lines. So from 2 milliliters minus 1 milliliter, that's just a 1 milliliter space. And there are 10 divisions, or 10 spaces. So that means each space is 0.1 milliliter. So now if this syringe, I'm going to change colors a little bit to make this darker, happens to be filled to here. Well, this is 3 whole milliliters. Each space is 0.1, so that's 3.1, 0.2, 0.3, 0.4. 3.4 milliliters. This syringe may also still be labeled in milliliters, but might be labeled like that. And let's say it is filled to there. So it touches the line. Again, we have to figure out what each division stands for. So we go from the 1 to the 2. Those are clearly marked. Now we see that there's major divisions here. So I'm going to cheat. There's 1, 2, 3, 4, 5 spaces there. And there's 1, 2, 3, 4 of those larger blocks. So there's 4 blocks of 5. So how many spaces is that? 20. And that's from 1 milliliter to 2 milliliters again, so that's 1 milliliter. So that means each of those spaces is 0.05 milliliters. So, filled to here, this was 2 milliliters, 2.05, 2.10. This is 2.10 milliliters. We might have one measured like this, or labeled like this, I should say. And it's filled like that. So again, we pick any 2 clear marks. It doesn't have to be from 1 to 2. I could go from 6 to 7 if I wanted to. Or 1 to 2, it's going to be the same. Either way, I'm looking at a 1 milliliter space, and I have 1, 2, 3, 4, 5 spaces between 1 milliliter divided by 5. That's 0.2 milliliters per space. So this is 3. That would be 3.2 milliliters. Now, I am going to argue that you would not want to use this syringe for 3.2 milliliters of medication if you could avoid it. It would be much better to use this syringe. Can anybody tell me why? Well, first of all, what's that? Because you can be more accurate, more precise, yes. First of all, let's fill this up. Tell me where to stop. Right there. Right? I heard somebody start it. Yeah. It's hard when I'm moving. So yeah, it's going to stop right there. This syringe here is a lot fuller than this one up here. A fuller syringe is always more accurate. The reason being is the way they get these divisions closer together is this syringe up here probably has a larger diameter than this one. It probably has a much smaller diameter. That's why the spacings are further apart, because it takes more distance to get the same volume. Whenever you do a syringe, you're never going to be exactly on the line. We're not exactly on the 3.2. We're not exactly on the 3.2 here. But if we're off by just a small amount, this one having the large diameter is going to be more, there's going to be more medication in that small distance. This one being a smaller diameter, there's going to be less medication in that distance. So the fuller the syringe is, the better. You don't want to administer 3.2 milliliters with this syringe because, again, that little bit of distance you might be off is a larger amount of medication. You want to match the dosage to the size of the syringe. So you want to get the syringe as full as possible. So let's say I am given the 2 syringes. And the dosage I need to administer is 2.6 milliliters. Which syringe do I want to use? The top one. Why?
Oh yeah, you're right.
2.6 won't quite fit in the bottom one, will it? And we'd really rather not stick a patient twice. Right? 2.6, maybe somewhere in here. If the dosage, however, was 1.8 milliliters, then we would definitely want to use the bottom one. Is that the correct dosage for 1.8 milliliters? Careful. From here to here, 1, 2, 3, 4, 5 times 1, 2, 3, 4. There's 20 divisions, right? 1 milliliter, each division is 0.05 milliliters. So this is 1, well, it's easier to count back from 2. This is 2. This would be 1.95. This would be 1.90. 1.85, 1.8 is going to be this one here. So you gotta be careful. It's easy to look at and say, hey, 1.8 is 2 milliliters or 0.2 milliliters less than 2, so it's 2 divisions. Make sure you know what the divisions are. So determine what the dosage is in here right now. In your notes, see if you can figure that out. For those of you that can't see real well, I'm one line past this big one here. This is 0.5 and this is 1 milliliter. So from here to here is actually 0.5 milliliters. And if we counted them, there's 20 divisions. So each division is 0.025 milliliters. What I would normally do with something like that, by the way, is I would figure out how many divisions it takes to be 1/10 of a milliliter. Times 4 would be 0.1 milliliters. That's easier for me to count up. So this is 0.5, 1, 2, 3, 4, that would be 0.6. 1, 2, 3, 4, that would be 0.7. Now this would be 0.725, 0.75, and this is 0.775 milliliters. One last one. Tell me what that dosage is. So from here to here is 0.1 milliliter, and that's 10 divisions. So each division is 0.01 milliliters. So this is 0.4, 0.41, 0.42, 0.43, 0.44 milliliters. So the key is figuring out what the scales are. Any questions on those? Anybody need to see more examples of those? Okay. So then our next step, get rid of that. We're going to start talking about dosage calculations. There are actually 3 ways to do dosage calculations. The first 2 methods we've actually seen, but not necessarily done in the form of a dosage calculation. The first method is a proportion. A proportion is when we have a rate or a ratio and we're looking for an equivalent rate or a ratio. Remember, we discussed this a little bit last week and a little bit before that. How do you know whether you're using a proportion or a unit conversion? How do you know when you're going to cross multiply and divide, or if you're canceling out and multiplying straight across? A proportion is when you're cross multiplying and dividing, and that's when you have the same units. For example, let's say you have a medication that is said to be 4 milligrams per kilogram. That is a rate. And you want to know how much for a 32 kilogram patient. Well, 4 milligrams per kilogram becomes 4 milligrams over 1 kilogram. And we want to know how much medication to administer to the patient. Well, we have the 32 kilograms, so we still have that amount. We just want to know how many milligrams, so we're still going to have milligrams as well to administer. So we still have the same units. We have milligrams and kilograms, and we're working with milligrams and kilograms. So we're not changing the units, we're just changing the size of the numbers. And that's when we set up a proportion like this. So we're going to find this number here by cross multiplying and dividing. 4 times 32 divided by 1 is going to give us 128 milligrams. Also should be noted here, milligrams and milligrams, kilograms and kilograms line up with each other. Our second method has a fancy term of dimensional analysis. The more generic term is just unit conversions. Now, the ones that are done with dimensional analysis could be done with proportions as well. For example, the one that we just did up here with the proportion, we could use dimensional analysis on that, bless you, if we wanted to. So we have a patient that is 32 kilograms, and we know that it is 4 milligrams per kilogram. We could use this as a conversion factor if we wanted to. Put the 32 kilograms over 1 to make it a fraction. We're going to put kilograms on bottom and milligrams on top so that the kilograms will cross cancel. And it's 4 milligrams per 1 kilogram. So now what we have here, 32 times 4 milligrams is 128 milligrams. 1 times 1 is 1. So 128 milligrams over 1, or just 128 milligrams. Same answer we got up here. We might have a medication that has a concentration of 2 milligrams in 25 milliliters. And the order is for 20 milligrams to be administered. This could be done using either the unit conversion or the proportion. I always prefer to use the dimensional analysis or the unit conversion. I'll show you that way first. Take the doctor's orders, 20 milligrams, make it a fraction by putting it over 1. We're going to convert. What has to go on bottom here? Milligrams, because we're getting rid of milligrams, right? So the milliliters are going to go on top. Now our relationship is 2 milligrams in 25 milliliters. So 2 milligrams, since milligrams are on bottom, the 2 goes on bottom, in 25 milliliters. Milliliters were on top, so the 25 goes on top with the milliliters. So the milligrams canceled out. 20 times 25 is 500 milliliters over 1 times 2 is 2. That divides out to make 250 milliliters. like I said, I could have used the proportion on this. To do the proportion, I would use that concentration, 2 milligrams and 25 milliliters. Where does my 20 milligrams have to go? Well, it has to go with the other milligrams, right? So 20 milligrams would go on top. And to find the number of milliliters to administer, I'll cross multiply and divide. 25 times 20 divided by 2 is 250. So either way, I get 250 milliliters. We'll come back to those methods more next week, especially the dimensional analysis. That's my favorite method, but I'm going to give you guys each a chance to pick which method you prefer. And starting next week, we'll still do some examples each way, but we'll kind of zero in on the method that works best for you. The dimensional analysis, as I'll show you next week when we do more of them, is just a lot more versatile. It works for pretty much everything. But anyway, the third method, which I'm going to show you right now, is the dosage calculation formula. Come on. I'm showing it to you last because it is my least favorite method, partly because I don't like memorizing formulas. For some of you, it may be the way you prefer to do it. For those of you that are in the ADN program, in your clinicals, you'll get a dosage calculation book, and you'll have to pass a dosage calculation test each semester. And the way that book teaches it is using the dosage calculation formula. The problem is there are like 5 or 6 different processes out there, and each of them require a different formula. So you have to memorize the different formulas and when to use them. Dimensional analysis can be used on all of those processes if you know how to match things up. So over the next couple of weeks, we'll look at those different types, and we'll show you how the dosage formula would work and then how dimensional analysis would apply. The dosage calculation formula is the amount to administer, A, is equal to the doctor's orders, D, over the on-hand dose, H, times the vehicle. So D is the doctor's order, H is the on-hand, and V is the vehicle. Now the doctor's orders here are relatively transparent. It's the on-hand and the vehicle that are a little bit more difficult to understand. In the example we just did, doctor ordered 20 milligrams. That's obviously capital D, the doctor's orders. The medication at a concentration (2 milligrams in 25 milliliters). This is actually both the on-hand and the vehicle. The on-hand amount is the 2 milligrams. The vehicle is what carries that into the patient. What's going to carry the on-hand dose into the patient? So it's what carries the 2 milligrams into the patient? The 25 milliliters. That is the vehicle. So to do this calculation, first of all, by the way, D and H must have the same units. If they don't, this is not going to work. The units that you're going to administer are going to be the units of the vehicle. So for this one, the amount is going to be administered. D, the doctor's order, is 20 milligrams. Over H is 2 milligrams. Times the vehicle of 25 milliliters. Now the reason the doctor's orders and the on-hand dose have to have the same units is so that they'll cancel out. Milligrams and milligrams cancel out. They divide out. 20 divided by 2 is 10. So we take that 10 times the 25 milliliters, we get 250 milliliters, which is what we got for both the proportion and for the dimensional analysis. So let's say we have a doctor that orders 1,000 milligrams of ibuprofen. Look at the label on the bottle. And the label says 400 milligram tablets. This example is why I'm not a big fan of the dosage calculation formula. Doctor's orders here are relatively easy to pick out. What are they? 1,000 milligrams. The on-hand dose is actually somewhat easy to pick out because it has to have the same units as the ordered dose, which is milligrams. So obviously the on-hand dose has to be 400 milligrams. What's the vehicle? Well, what carries the 400 milligrams into the patient? There it is, exactly. One tablet. One tablet contains the 400 milligrams. That is what will carry that medication into the patient. So now, again, the milligrams cancel out, divide out. 1,000 divided by 400 is 2.5. Times one tablet, well, 2.5 times one tablet is 2.5 tablets. So let's say the order is for 450 milligrams. The label on the bottle says concentration. "20 milligrams in 15 milliliters. Find the amount to administer to the patient. I'm going to pause for a second. I'm going to see what you come up with. What goes on top of our fraction? 450 milligrams is the ordered dose. Perfect. What goes on bottom? 20. It has to be milligrams, so the only other milligrams in the problem is the 20. Times, what's our vehicle? 15 milliliters. So the milligrams divide out. 450 divided by 20 is 22.5. Good. Times 15 milliliters, 337.5 milliliters. Should administer 337.5 milliliters. Any questions? Okay, let's look at another example. Trying to figure out how to write this one out. We'll just do this. Orders for 1,300 milligrams. A label is for 500 milligram scored tablets. Scored tablets means that they are marked and scored so they can easily be cut in half. when you're using scored tablets, you're going to round to the nearest 1/2 tablet. So in your notes, see what you come up with for this one. So it goes on top. 1,300 milligrams. On bottom, 500 milligrams. Times 1 tablet. Milligrams divide out. 1,300 divided by 5. 2.6 times 1 tablet is 2.6 tablets. But we round to the nearest half. Very good. So that's going to end up being 2.5 is what you're going to actually administer. Let's do one similar to that. Let's say the doctor's order is for 700 milligrams. And the label is 300 milligram tablets. Again, I want you to quickly figure this one out in your note. I should have labeled that. This is scored tablet. Go to the nearest half tablet. So what goes on top? 700 milligrams. Very good. Bottom, 300. And of course, times 1 tablet. Milligrams divide out. 700 divided by 300. 2 1/3 or 2.33, right? Times 1 tablet is 2 1/3 or 2.33 tablets. Now again, though, we're rounding to the nearest half tab. Is that closer to 2 or 2.5? 2.5. Because we're looking at here's 2 and here is 2.5, right? Halfway between would be 2 1/4 or 2.25. And this is 2.33. So we're closer to the 2.5. There's one similar to that on the next unit test, by the way. The reason I bring up that example is a lot of people get that one wrong because they do exactly that. They round it down because they think 1/3 is closer to 2 than it is to 3, but we're going to the nearest half, so it's closer to 2.5. So let's say the order, 50 milligrams, our label, 2 milligrams and 25 milliliters. So I'll figure out how much to administer. So, in our formula, on top, 50 milligrams, bottom, 2 times 25 milliliters. Good. Milligrams divide out. 50 divided by 2 is 25 times 25 milliliters is 625 milliliters to administer. Very good. Now, this all works backwards as well. Let's say that the label says the concentration is 3 milligrams in 5 milliliters. Looking at the chart, what was administered in the last time around was 100 milliliters. Problem is, this bottle is now empty. New bottle is labeled 2 milligrams in 15 milliliters. So I'm going to start with what was on the chart and what was the old bottle. We don't know what the ordered dose was. That's what we're going to be solving for. What was administered was 100 milliliters. What was on hand was 3 milligrams. And the vehicle was 5 milliliters. We know this had to be, the doctor's order had to be in milligrams. We know that much. To solve for D here, I'm going to divide by the 5 milliliters. Now the reason I divided by that first instead of multiplying by the 3 milligrams is this is milliliters. So dividing by the 5 milliliters not only gets rid of the 5 milliliters, but it also gets rid of the units on this side. So the milliliters cancel out. 100 divided by 5 is 20. So 20 equals my doctor's orders over 3 milligrams. So now to solve, I'm going to multiply by 3 milligrams. 20 times 3 milligrams was 60 milligrams. So the doctor's order was for 60 milligrams. To work it the other direction, our new label on our new bottle was 2 milligrams and 15 milliliters. So now 60 milligrams over what? 2 milligrams times 15 milliliters. Milligrams cancel out. 60 divided by 2 is 30 times 15 milliliters. So this new medication is going to have to be 450 milliliters administered. So let's test your algebra skills a little bit here. Chart shows for a medication with a label of four milligrams and 25 milliliters. 300 milliliters was administered. Find the doctor's orders. So we try that in your notes. So when we set this up, do we know A? Yes, that's going to be 300 milliliters. D is what we're looking for. H, 4 milligrams, and V, 25 milliliters. What'd you do first? Divided by the 25, okay? So the milliliters over here cancels out. 300 divided by 25 is 12. Then what? Times the 4 milligrams. We get 48 milligrams. So the doctor's orders was 48 milligrams. Now, one thing to make sure you get used to, you'll notice here in these calculations, I did include the units at every step, and I worked with the units at every step. That is something to get used to, especially if you are in the nursing program or going into the nursing program. I'm going to get very picky about that. And it can be very critical. For example, let's say that the label on the bottle is, again, 2 milligrams and 5 milliliters. And on the chart, what was administered is, let's do this. We get a little practical. That. So our administered dose, that is 800 microliters, is equal to the doctor's orders over 2 milligrams times 5 milliliters. We go to divide this out right now. If we're not putting the units in there, we would just do 800 divided by 5, and we would not notice that they are different units. Right now, that 800 cannot be divided by the 5 because they're different units. We have to convert the 5 milliliters into 5,000 microliters first. Then we can divide by the 5,000. So that the units divide out. The units at this step must divide out. So now we've got 800 divided by 5,000 is 0.16. Now we're going to multiply by 2 milligrams. So 16 times, or 0.16 times 2 is 0.32 milligrams is the doctor's order. Chances are, and we could leave it as 0.32, that's fine. Chances are that was really 320 micrograms was the doctor's order. Okay, it's about that time where we're going to lose our connection soon. So, pages out of your book to look at. On page 146, 1 through 17, the odds. Page 153 through 154. 1 through 15, I'm going to have you look at all those. I believe that's just most of your vocabulary stuff. Page 162 through 163. 1 through 23, the odds. That's the dosage calculation formula. And page 168 through 169. 1 through 19, the odds. That's dealing with the syringes. So next week, we'll still be working on this unit, and I believe I'm going to take one more unit to go through this. We'll see how we do next week. There is a chance, though, that our Unit 3 test will be 2 weeks from today. That's the original plan, but I may stick one more week in this unit.